All right, so Chapter 9, Section 5 deals with dividing radicals. So, just like the previous section, I'll start off with the big property that we're going to be using, which is the quotient property of square roots, which basically states that if a and b are non-negative real numbers, and b does not equal 0, because remember we don't want a 0 in our denominator, then we have the following here. So notice, and I'm going to start over here on the left-hand side. So notice we have the square root of a over b, which is equal to the square root of a over the square root of b. In other words, if we wanted to, we can break up the radical into the numerator and denominator. And on the right-hand side, we could do the exact opposite order. If we have them broken up, if we wanted to, we can just combine them into one fraction with a big radical symbol. So all I'm going to do here is just basically use this property over and over again. And the key is to always try to simplify if you can. So I got a bunch of examples here I'm just going to go through. So let's go ahead. Let's look at this. So notice square root of 27 over the square root of 75. It's already broken up. I kind of like that. More importantly, I noticed that the square root of 27 is really just 9 times 3. And the square root of 75 is really 25 times 3, which means I can break that down. Square root of 9, we know, is 3. Square root of 3 over square root of 25 is going to be 5 square root of 3. And finally, and I'll highlight so you can see it, notice that we have the square root of 3 in a numerator, square root of 3 in our denominator. They reduce into a 1. So the final result is just 3 over 5. Okay? So I'm just going to keep going now. So let's go ahead. Let's look at this next example. So we got the square root of 96 over the square root of 54. Okay? So the square root of 96 can be rewritten as 16 times 6. And then the square root of 54, well, that could be rewritten as 9 times 6. I know from simplifying, the square root of 16 is going to be 4 square root of 6 over 3 square root of 6. Finally, the square root of 6's will reduce to give us 4 over 3. So, like I said, this kind of ties into everything that you've learned about, like, simplifying fractions, simplifying radicals, all that good stuff. Now, this next one here, notice that in the numerator, I mean, I could reduce some stuff if I wanted to. Like, the square root of 12 is really 2 times 6 or 4 times 3. But watch what I do here. I'm going to rewrite this. It's just one big radical symbol. All right, and the reason why I did that is I noticed two things. First, 12 divided by 6 is going to be 2. And then the second is r to the third divided by r to the first. I can use my quotient rule. R to the third divided by r to the first is really just going to be r to the second. So now from here, I can simplify, because I could break this up as the square root of 2 times the square root of r to the second. And we know that the square root of r to the second is just r times the square root of 2. So sometimes it pays off if you just take a second, look at what you got, and say, oh, I can easily reduce that real quick. All right? Other times, not that easy. It doesn't matter which way you do it. You're always going to get the same exact answer. Okay? So as you can see here, we got a couple more. So let's just go ahead and do this. So for this one, I'm not going to rewrite it as one big fraction. I'm going to leave it like this. So let's see here. Square root of 50 is really 25 times 2 x to the third over 128 is really 16 times 8. I'll leave it as times 8 for now, over x. And the reason why I'm doing this is just so I can reduce whatever I can. I can see some of these, so it's kind of a little bit easier for me. You'll get there. You just got to keep practicing, and you'll start to see stuff. Square root of 25 is 5. Now, this x to the third, I can pull 2 x's out and leave. square root of 2x inside, over square root of 16, well, that's going to be 4 times the square root of 8x. But if I think about it, I can further reduce that square root of 8x. So I'm just going to rewrite the numerator here. The square root of 8x is really just 4 times the square root of 4 times 2x. And the square root of 4 is really 2, so I have 5x to the second times the square root of 2x over 4 times 2 square root of 2x, which is really 5x to the second times the square root of 2x over 8 square root of 2x. And then square root of 2x in the numerator and denominator will reduce to give 5x to the second over 8. Okay? Now we're going to do the last example here. And this example, I think it's only fair that I write this as just one fraction so you can see that again. All right, so I get 147 AB to the 8th in the numerator. I get 3 A to the 3rd B to the 4th in the denominator. And what I'm going to do here is I'm going to try to simplify whatever I can. So I think, if I'm right, 147 is really 3 times 49. And that just happens to be so nice because when you think about it, underneath the radical, the 3's reduce. So that's nice. So I'm just going to go ahead and just write another radical symbol here. The 49 stays in the numerator of my fraction. Now, a to the first divided by a to the third is a to the second. B to the 8th divided by b to the 4th is going to be b to the 4th. Now, before I move on, sometimes I get students and they go, well, how did that a to the second, how did you know that goes in the denominator? And how did you know the b to the 4th goes in the numerator? Okay? Remember, you can always think about it like this. 1, 2, 3, 4, 5, 6, 7, 8. You can always think of it as 1a and then 8 b's, and then in the denominator, 3 a's and 4 b's. And all you got to do is just reduce what you can. So notice, here are those 2 a's in the denominator, and then 1, 2, 3, and 4. There's all the b's, and notice that I have 4 b's left over in my numerator. So that's how I got the square root of 49 b to the 4th over a to the second. Now, I'm just going to separate, because I can easily see the square root of 49 is 7. The square root of b to the 4th is b to the second, over the square root of a to the second is just a. So 7b to the second over a. Now, all these examples that we just did are the really nice ones. They're the ones that make us feel really good because it's just simplifying something. All right? Sometimes you run into a situation that is called rationalizing the denominator. So first, and before I even read this, let's just look at this first example. 5 over the square root of 3. As mathematicians, it's okay to have a square root in the denominator, but we just don't like it, okay? And the reason why we don't like it is it just looks ugly. And I'm sure there's a better reason out there that I'll have to look up, but I can't think of it, or I can't remember it right now. It's been a long time. But what I do know is this. If you have a square root in the denominator, the technique that we use to convert this fraction with a radical in the denominator to an equivalent fraction whose denominator is an integer is called rationalizing the denominator. In other words, our goal is to have another fraction where your denominator is strictly an integer. It's a number. It's not a radical. There's no square root symbol underneath. Now, if you think about that, and I'm going to erase this here. What we're going to have to do is convert this fraction to, and here's the key word, or keywords, equivalent fraction. In other words, when I put this equal sign here, this fraction that I'm going to put a box around when I'm done has to be equivalent to the one that I have here. So if you think about that, if you have a fraction and your answer has to be basically the same exact fraction, the only thing that you're really allowed to multiply by is 1 over 1. Because if you think about it, 1 over 1 is 1, which is an equivalent fraction. Okay, it's going to give you an equivalent fraction. It's like 5 times 1 equals 5. 5 on the left, 5 on the right, it's equal. However, now hopefully you can see that I'm erasing, because we know, and if you look on the right-hand side of your screen, we know that there are plenty of ways to write the number 1. There's a bunch of ways. For example, we can write 1 over 1. Well, that equals 1. If we wanted to, we could write 5 over 5. That equals 1. We could also write -3 over -3. That equals 1. In fact, the square root of 3 over the square root of 3 is still the number 1. So if I use this idea that the numerator and denominator are the exact same numbers, I can use that to my advantage. Because when I look at the denominator that I have, and I'm going to highlight it here for us, if I look at the square root of 3, well, I know that if I took the square root of 3 times the square root of 3, that gives me 3, which is an integer. Now, I just need to be really clever, because I know if I have 5 over the square root of 3 as a starting fraction, and I want an answer whose denominator is an equivalent, or I'm sorry, whose denominator is an integer, that's an equivalent fraction, then this number right here in the middle, so hopefully you can see this big red arrow that I'm drawing here. All right, that number that I'm going to multiply by has to be the number 1. I just need to be really clever on how I write that number 1. So if I take square root of 3 over the square root of 3, I know that equals 1, lower right-hand corner. But if I multiply from left to right, because that's how we multiply fractions, in the numerator, I'm going to get 5 square root of 3. But then in my denominator, I get an equivalent fraction whose denominator is an integer. So I get the same exact thing. Okay? So the key to this is called rationalizing the denominator. So look at the denominator, and whatever that denominator is, that is what you're going to multiply by. So let's look at another example now. Let me erase this stuff on the right-hand side so I have some space. All right, so 6 over the square root of 5. Well, I don't like that square root of 5 in my denominator, so I'm going to rationalize the denominator by multiplying by the square root of 5 over the square root of 5. My numerator is just 6 times the square root of 5. However, my denominator, square root of 5 times the square root of 5, is really the square root of 25, which we know to be 5. Okay? So that's as easy as it gets. I'm just going to do a couple more examples here for us. So here's another example. Now, who cares about the negative sign? Because that's not even in my denominator. I'm not worried about that. And I don't even have to be concerned with this 2 out front. The only thing I'm worried about is that radical right there. So let's multiply this by the square root of 5 over the square root of 5. That's going to equal a negative symbol out front. My numerator is going to be 5 times the square root of 5. Now my denominator, you just got to be, it's not tricky, you just got to write it. 2 times square root of 5 times the square root of 5 is the square root of 25. But we know that simplifies down into 2 times 5, which is, now, don't multiply 2 times 5. I know you want to. I know you want to write 10, and I get it. But let me highlight something for you here. Notice you got a 5 in a numerator and a 5 in a denominator. They are going to reduce. So your numerator is really square root of 5 with a negative sign out front, and your denominator is just a 2. So remember, you always want to simplify things, okay? Don't be so quick to just start multiplying everything, because remember, to simplify a fraction, you can break it down into its prime factorization and then reduce what you can. All right, let's try this one here. Now, first thing I see is this big radical symbol around the outside. That's the first thing I see, okay? And then the second thing I see is that I have a fraction underneath. So, first thing I'm going to try to do, simplify the fraction. Unfortunately, 3 over 2, or 3 over 32, does not simplify. So, let's break it up. Now, I'm going to just go ahead, multiply top and bottom by the square root of 32 over the square root of 32. And this is not the only way to do this. It's just one of them. So in my numerator, I'm going to get the square root of 3 times 32. In my denominator, I just have number 32. And what I'm going to try to do is I'm going to try to break that 32 down. All right? So leave the 3 there. I know 32 is really 16 times 2, okay, over 32. Now, the reason why I did that is because I know right here in the middle, that square root of 16, well, that's going to be 4. So I get a 4 out front, and then 3 times 2 is 6 left over on the inside. And finally, I can reduce this fraction because 32 is 4 times 8. And the 4's will reduce to give me the square root of 6 over 8. Okay? Last one. The square root of 10 over the square root of 10 over 50. So here I can definitely reduce to 1/5. Okay? Then I'm going to separate square root of 1 over the square root of 5. Square root of 1, I can do that. That's just going to be 1 over the square root of 5. And then finally, we will rationalize our denominator to get a final answer of the square root of 5 over 5. Now, I said this is the last example of this type. Because if you notice, and I'm going to highlight it here for us, I'll highlight it in this nice purple color I like. If you notice, every single example we did, we ended up having one radical in the denominator. So that's right there. Boy, that purple is really bad. Let's use a different color. I'm sorry about that. Let's do the green. I guess that's all right. So there is the one radical. Here is the one radical. There is the one radical. Here is our one radical. And even up above, we just had one radical. All right? Now the question becomes this. What if you have two things in the denominator? What if you have two of them? 4 over 4 plus the square root of 2. Well, hopefully you're thinking, well, everything that we've done so far, we multiplied by 1, but we wrote 1 in a very clever way, okay? Now, if you're thinking, well, why don't we just multiply by the square root of 2 over the square root of 2? Well, watch what happens if we do this, okay? In the numerator, you get 4 square root of 2. However, in your denominator, you have to distribute. You got to distribute. So we get 4 square root of 2 plus 2. Notice you still have a radical in your denominator. So this move here didn't work for us. Okay? It didn't work because we still got a radical in that denominator. We don't want that. Now, there is something that we've learned. We've seen it multiple times throughout the semester, and we even gave it a name. What we're going to do is multiply by that conjugate. So instead of it being 4 plus the square root of 2, we're going to write 4 minus the square root of 2. Now, in the numerator, watch what happens. 4 times 4 is 16. 4 times a negative square root of 2 is minus 4 square root of 2. And here's the beautiful part. In the denominator, since we have conjugates, 4 times 4 is 16. Positive 2 times positive square root of 2 times negative square root of 2 is minus 2. Notice in your denominator, there's no radical symbol anymore. It's in the numerator now, which is fine. Numerator is fine. So here, I got 16 minus 4 square root of 2. All over 16 minus 2 is 14. And then you're going to have to reduce this. So the easiest way for me to show you this is to separate and then reduce each fraction. And I know it's not exactly the funnest thing to do, but it is what it is. So we're going to get 8 over 7 minus 2 square root of 2 over 7, or 8 minus 2 square root of 2 all over 7. Okay? Now let's look at this example. Once again, we're going to multiply by the conjugate. So our conjugate here is going to be 2 minus the square root of 3. 2 minus the square root of 3. So 2 times 2, 4. 2 times negative square root of 3 is 2 times the square root of 3 with a minus sign in front. Here's my favorite part. We got the conjugates. 2 times 2 is 4. Square root of 3 times negative square root of 3 is minus 3. So we get 4 minus 2 square roots of 3 all over 1. Or just 4 minus 2 square root of 3. Okay? We'll try one more that kind of looks like this. Hopefully now you've caught on. We're going to multiply by the conjugate. So distribute. 3 times 1 equals 3. 3 times the square root of 5 is going to be plus 3 square root of 5. All over 1 times 1 is 1. A negative times a positive is a negative. Square root of 5 times square root of 5 is going to be 5. So we get 3 plus 3 square roots of 5 all over negative 4. And since nothing reduces here, we just circle the answer. Now, this last problem I have here, it looks different because notice in my denominator, I have radical symbols. However, the process is still the exact same. You're going to multiply by the conjugate. So the conjugate will be square root of x minus square root of 2. Square root of 5 times the square root of x is going to be the square root of 5x. Square root of 5 times the square root of square root of 5 times negative square root of 2 is going to be negative square root of 10. All over. Now these are conjugates, so remember, x times x, or square root of x times square root of x is x. Positive times a negative is a negative. Square root of 2 times square root of 2 is 2. And since these radicals in the numerator cannot reduce, you're done. So the key to this entire section is just being able to recognize that we don't like square roots in our denominator. So we just simplify them as much as we can. Sometimes, and I'm going to scroll up, sometimes we get really lucky where we can simplify it very easily, like in our very first example. Okay? Other times we're not that fortunate, and what we're going to have to do is rationalize the denominator. And there are two ways to do this. The first way is if you have one single radical in a denominator, whatever that is, you write it. The second way is multiplying by a conjugate. So that's going to be it for this lecture video. In the next one, we're going to explore how do we solve equations that contain radicals. So I'll go over that in the next video. Talk to you later.